Okay, so this just talks about the use of another antenna to kind of boost performance or bend the magnetic coupling to our will. So you can see that the XLED doesn't really light until about here, which is about 10 millimeters off the surface. And if we place it in the middle of this, we kind of get the same performance. There's no real difference. However, if you place it perpendicular, perpendicular to the existing antenna, we get a huge range increase where we start to see, a reaction to the field. Now it's not very bright. It doesn't get very bright until you get within the normal range, but it does activate. The efficiency is pretty bad. Now that would be enough for a chip, a microchip, to engage. That's probably about half to a third, well, a quarter, half to a quarter of the current, or probably voltage actually, that you would see normally, a chip engaged. So you get maximum brightness, maximum watts out of the coupling. But when you're talking about an LED that's pulling, I would guess anywhere between 15 and 20 milliamps to light appropriately, a microchip is going to pull considerably less than that if it's doing just basic stuff, maybe not encryption, but that's the point. Is you could probably let's see, I have an XNT. No, that's my XEM. My XNT is here. So XNT here, but now it's impossible to know if I'm talking to this or to my XNT. So really what we need is an antenna designed like this with the chip removed and a capacitor of equal capacitance put across those two things. So you just have like a tank circuit with nothing else, no actual chip involved in this. Then you place that essentially over your cylindrical implant so that the rings run perpendicular to the implant, and then test. And I think you're going to get probably some good performance out of it. So that's a test for another day.